Okay, so we've all been there, right? You're staring at a new problem, blank page, blinking cursor. That feeling of like, ooh, where do we even begin starts to creep in.
Yeah.
But today, we're kind of flipping the script on that whole fear thing.
Oh, yeah.
Yeah, we're diving into this blog post from Algo Academy. It's called The Art of Starting from Scratch. We're going to uncover why that blank slate, the one that usually freaks us out, might actually be like a secret weapon. And not just for coding, for anything you want to tackle.
You're absolutely right. We tend to think about starting from scratch as like a bad thing, a disadvantage, when it can actually be like super liberating.
It is.
It's kind of like someone just gives you all these ingredients but no recipe and you have to figure it out. You got to get creative.
Totally. And, the article jumps right into 5 reasons why this starting from scratch mindset is so powerful. One that I thought was super interesting was this whole fostering innovation thing.
Oh, yeah.
Like, if you're always just following a template, you're never really going to, break new ground.
Absolutely. I mean, think about like some of the most innovative products or solutions out there, right? They often come from people who are just looking at the problem with like fresh eyes. They're not weighed down by like all those preconceived notions.
Right.
For example, in the world of design thinking, starting from scratch is like the key.
Yeah.
To like really uncover what users actually need and then, coming up with solutions that are truly innovative.
Yeah. It's kind of like, that famous story about the Post-it note, how it was originally like a failed adhesive.
Right.
And it ended up totally revolutionizing the way we work.
Exactly.
So the article then goes on to lay out a 6-step process for actually approaching a problem from scratch.
Yeah.
For you, what stands out in that process as like the most crucial steps?
Well, to me, I think it's really all about understanding the problem thoroughly.
Okay.
Which I know it sounds pretty obvious,
Right.
but honestly, it's something that people overlook a lot. It's about really dissecting the problem. Like, what are you actually, trying to solve here?
Right.
What are the limitations? What are we working with? It's like, when you lay the foundation for a house, if the foundation's shaky, the whole thing's going to crumble.
Yeah, they're going to have problems.
Yeah, you're going to have big problems.
Right. Skipping that first step could lead to like a ton of wasted effort later on.
Oh, absolutely.
And then comes breaking the problem down, that whole like divide and conquer
Yeah.
approach.
Yeah.
Have you ever like run into a situation where that breaking it down made all the difference?
Oh, all the time. Yeah, I definitely remember I was working on this particularly complex research project. The data was it was overwhelming.
Yeah.
It wasn't until we actually sat down and, broke it down into smaller, more manageable questions that we started to see the patterns emerge.
Oh, that's cool.
Yeah.
Okay, so that's a great example of how this idea applies, beyond code.
Right.
It's about making the seemingly like impossible possible.
Right.
So the third step in the process, they talk about identifying patterns and analogies, which I always find interesting.
Yeah.
I think the way they explain it with the whole palindrome thing in the article was really clever, but it might have been a little too like techie for some people.
Yeah.
How would you explain that to someone who isn't, a coder?
Imagine you have just this giant, chaotic pile of toys, right?
Sure, yeah.
And you're trying to, organize them. Well, you'd probably start by grouping them based on, how they're similar. Like cars in one pile, stuffed animals in another. That's basically the same principle.
Okay, so it's about recognizing.
You're looking for patterns or relationships that can help you make sense of the problem.
Gotcha. So you're not like directly copying a solution, but you're recognizing that certain approaches can be used in different contexts.
Exactly.
It's like having this mental toolbox of strategies that you can pull from.
Exactly. And that's where experience really comes in.
Okay.
The more problems you solve, the more patterns you recognize, the bigger your toolbox gets.
So we've understood the problem, broken it down, found some potential patterns. What's next? Do we dive into building like the perfect solution?
Well, not quite.
Okay.
The article actually recommends starting with like a really simple solution,
Mm.
even if it's not the most like elegant or the most efficient.
Okay.
The goal at this stage is just to get something working.
Okay.
You want to have something, tangible that you can actually iterate on.
So it's more about like momentum at this point than perfection.
Precisely. Trying to get that perfect solution right out of the gate can be like totally paralyzing.
Yeah.
It's much better to, kind of embrace the imperfection and see each iteration as a step toward a better solution.
So it's kind of like sketching out a rough draft before you start, the detailed painting. You need that foundation to build on.
Exactly. And that actually leads perfectly into the next step, optimization. This is where you start refining that solution, making it more efficient, more robust, the whole 9 yards.
Okay, but I'm curious. Wouldn't you want to think about efficiency, like from the very beginning? I mean, why build something that you know you're going to have to redo later?
That's a great question. And it's actually where the article brings up this thing called premature optimization.
Hmm.
It's this idea that sometimes, when you get caught up in trying to fine-tune things before you even like fully understand the problem or have something that works, it can lead you down this rabbit hole
Oh, yeah.
of complexity and wasted effort.
So it's more about like get it working and then you can worry about making it like super fancy.
Exactly. And, when it comes to optimization, the article mentions this thing called time complexity and space complexity.
Yeah, those sound kind of like techie.
Yeah, they
I
do.
think it'd be helpful to,
Yeah.
explain those in a way that anyone can understand.
Totally. So think of it this way. Time complexity is basically like how long it takes for your solution to, actually run. Imagine you're trying to sort a deck of cards, right?
Hmm.
If you have a method that takes forever with like a huge deck of cards,
Yeah.
that means it has high time complexity.
Okay.
Space complexity is all about like how much memory your solution uses.
Hmm.
So like if you have a program that eats up like a ton of memory,
Yeah.
just to do something super simple, that's high space complexity. Ideally, you want solutions that are, fast and don't use up all your memory.
Right. You want it to be efficient in both time and resources. Okay. So we've optimized our solution. What's like the final step in this whole process?
The last step, and it's definitely a crucial one, is testing and validation. This is where you basically just put your solution like through the ringer. You want to make sure it actually works, you know?
So we're not just like giving ourselves a pat on the back for creating something. We're actively trying to like break it.
Yeah, exactly. You want to challenge it, find its weak spots, and make it even better. It's like, stress testing a bridge.
Right.
You got to make sure it can handle anything that comes its way.
Okay, so those 6 steps give us like a really solid framework. But the article also throws in some extra problem-solving strategies that I thought were super cool.
Oh, yeah.
One that stuck out to me was visualize the problem. They even suggest like sketching things out for problems that aren't even, visual.
Right.
How does that work?
Well, you'd be surprised, even abstract ideas can benefit from a little visualization. Like, let's say you're planning this big, complicated project with, a ton of moving parts.
Okay.
If you sketch out a flow chart or a diagram, you can actually see how everything connects, the bottlenecks, and, like the most important tasks to get the whole thing done.
It's like untangling the mess in your head and putting it down on paper.
Exactly.
Another strategy they mentioned is think aloud,
Mm.
which I have to admit I do all the time. But like, is there actually science behind that?
There is. Saying your thoughts out loud forces you to, actually explain your reasoning. And sometimes that helps you find like gaps in your logic or places where you need more information.
Yeah.
It's a great tool not just for figuring things out yourself, but also when you're working with other people.
I totally agree with that. I feel like when I explain something out loud, even if it's just to myself, it's like things just click.
Yeah.
Like, oh, that's what I was missing. We talked a bit about analogies earlier, and the article really highlights how powerful they can be, especially for like really complex problems. Have you ever had a situation where an analogy like helped you solve something?
Oh, all the time. Way more often than you think. I remember one time I was stuck on this network optimization problem, and I just couldn't figure it out. Then I was watching this documentary about ant colonies and how they like find the best way to get to their food.
Oh, wow. Okay.
And it just like sparked an idea
Yeah.
for a whole new algorithm based on how the ants were behaving.
Yeah. That's amazing. So even just observing nature can give you insights into these complicated, technical problems.
Yeah,
Okay, the article also dives into some common pitfalls to avoid.
right.
And these aren't just for coding. They're for like any problem you're trying to solve.
Oh, for sure.
We've all been there.
Oh.
Overthinking, getting lost in the details, that whole trying to find the perfect solution right away.
Yeah, the article calls that premature optimization.
Yeah. I think we've all been guilty of that one at some point. Can you like give an example of how that might play out in a real life situation?
Totally. Imagine you're planning a trip.
Right.
Right. You could spend like hours and hours
Oh, yeah.
looking at every single hotel, every flight, every possible itinerary, trying to, save every penny or squeeze in every single activity.
Yeah.
But in doing all that,
Yeah.
You might miss out on like a really cool hidden gem hotel
Right.
or a spontaneous adventure that would have made the trip truly memorable. Sometimes it's better to have a good enough plan
Yeah.
and be open to, whatever comes your way.
It's like finding that balance between planning and being open to like new experiences.
Exactly.
The article suggests that one way to avoid these pitfalls is to focus on building what they call a minimum viable product or MVP.
Hmm.
What does that mean in the context of, problem solving beyond coding?
It basically means like strip away all the fancy extras and just focus on what's absolutely essential.
Yep.
Think of it like launching a new product. Sometimes it's better to get like a basic version out there,
Right.
get feedback, and then improve it rather than spending like years trying to make it perfect before anyone even sees it.
Right. You can always add stuff later.
Exactly.
Okay, so we've talked about the steps, the strategies, the pitfalls, but like, how do we actually get better at problem solving?
Right.
The article suggests practicing regularly, which, sounds obvious, but are there any tips on making that practice more effective?
One thing that I found really helpful is to like actively look for different kinds of problems. Don't just stick to, what you're already comfortable with. Yeah, yeah. Challenge yourself with like puzzles, brain teasers, even like creative exercises that force you to think outside the box.
Okay.
There's a ton of stuff out there online, and it doesn't have to be just about coding.
Yeah.
It's all about keeping your brain sharp.
Yeah, I really like that idea of cross-training your brain. It's like hitting the gym, but for your, problem-solving muscles.
Yeah.
The article ends by talking about like the beauty of the blank slate, that potential that's just sitting there in the unknown. I thought that was a really cool way to frame it.
Yeah.
It's not about being afraid of starting with nothing,
Yeah.
It's about seeing it as this chance to create.
Yeah. And I think that brings us back to like the big takeaway from this whole deep dive. It's about shifting your perspective,
Right.
right? Seeing that starting from scratch, not as, oh no, I'm doomed,
Right.
but as like, hey, this is an opportunity
Yeah.
to do something really cool.
Yeah, and so much of this really ties in with, that whole growth mindset idea.
Oh, absolutely.
It's not about knowing all the answers right away. It's about, being okay with that process of figuring things out. And that kind of brings me to a question for you, the listener. What blank slate are you facing right now? Is there a problem or a project that's got you feeling kind of stuck?
What if instead of looking at it like it's a problem,
Yeah.
you saw it as this like blank canvas? A chance to use these strategies we talked about, to experiment, to try things out and, work your way to a solution.
That's a great challenge to leave our listeners with. Don't be scared of the blank slate. Embrace it. And, remember, even the longest journey starts with a single step.
Or in our case, maybe a single line of code.
Until next time, happy problem solving.